Welcome to Global Water Solutions. In this video we will be demonstrating revolutionary water remediation technologies. These technologies provide treatments and pre-treatments for a wide array of water remediation applications. There are three main categories of water treatment plants that we're concerned with. The first is a non-hazardous waste industrial treatment plant. The second is a hazardous waste industrial treatment plant. And the third are municipal water and wastewater treatment facilities. Under each of these water treatment plant categories, we have many different types of target markets, including agricultural and chemical companies, mining and oil drilling operations, food processing companies, manufacturing companies of all types, pharmaceutical companies, municipal water and wastewater treatment plants. Virtually any industry that has water as a byproduct or that needs water to operate can use our technology. The water remediation technologies of Global Water Solutions removes many different types of total suspended solids, such as heavy metals, phosphorus, chromium-6, bacteria and viruses, chemical compounds such as benzene, chlorine, salts, BODs and CODs, and many, many more. The real benefits to our processes are as follows. We have processes that can clean water where no other company can. For example, other companies remove arsenic from drinking water with reverse osmosis. However, the percentage of recovered clean water is low and expensive, and the wastewater is a highly concentrated solution of water and arsenic that still has to be disposed of. Many companies are currently illegally disposing of that toxic solution and just paying their fines. Our system solves many problems by electrically coagulating the arsenic and other toxins with elements in the water, creating a compound that's easily removed from the water and safe to dispose of. Another benefit to our system is that it is highly cost efficient in terms of energy consumption. No other process can match our processing costs per gallon. Currently, many water treatment plants treat their water with added chemicals for purposes of leaching and masking. Other than adjusting the pH levels of our processed water, we use no chemicals at all. To clarify, Global Water Solutions is highly green by offering low energy consumption, safe non-hazardous waste disposal, high water return, and chemical-free processing. Our systems are scalable and can process from 100 gallons per minute to 5,000 gallons per minute based on required output. We can even engineer systems to fit client custom needs. Before watching some live videos from our plant operations, let's take a look at the schematic of a basic plant. It's very simple depending on the start water and the desired finished product. The entire process is highly efficient and often reduces treated barrel costs or cost per gallon exponentially. The first major component is the electrocoagulation system, or EC unit. It uses electricity to coagulate basic elements, both toxic and non-toxic, into complex molecules that are safe for disposal, often in non-hazardous landfills. The second component to a basic plant is the Advanced Mechanical Separator, or the AMS unit. It will further polish the water and reduce the particulate size down to 0.5 microns. The third element of the basic plant operation is the reverse osmosis system. The reverse osmosis system is often used when potable water or drinkable water is desired as an end product. However, depending on the application, perhaps only the EC unit is needed to clean the water to an acceptable level for disposal for reuse water. Sometimes the AMS system is needed and the process ends there, and sometimes the process ends with the reverse osmosis system. It all depends on the application, and this is just a basic flow chart to get an idea of how the plant operation works. So let's take a tour of the plant that's currently operating in Wichita, Kansas. The first station here is the tanker that pulls into the bay and unloads the water. You'll notice there's a high volume, low energy consumption pump in the lower right hand corner of the screen. That high volume pump pumps the contaminated start water from the tanker into one of these 8,000 gallon holding tanks. From the storage tanks, the contaminated water is pumped to our processing station, which contains several separatory tanks you'll see along the bottom of the floor, and the electrocoagulation unit, which is that blue unit up on the second floor. The machinery that you see underneath the staircase of this workstation are the advanced mechanical separators. So together, the EC unit, those separatory tanks, and the advanced mechanical separators make up our work processing station. What you're viewing now is the electrocoagulation unit in action. It's processing 50 gallons per minute. The scum that you're looking at on top of the water is actually coagulated particles that are going to be separated out from the cleaner water. From the EC unit, the treated water is gravity fed through a series of pipes and manifolds and can be diverted into these settling tanks. The settling tanks act as giant separatory funnels to separate the coagulated material from the cleaner water for either further processing or disposal. The settling tanks have conical bottoms to eliminate sediment buildup. Within the settling tanks, the constituent layers will start to settle out from a foamy top bottom to 3 layers where you have your target material or the cleaner water in the middle. After leaving the EC unit, the water can be further processed through our advanced mechanical separator or AMS unit. In this instance, we're looking at the fat boy, which is employed in this specific processing plant. Kurt is demonstrating the media filter that's utilized within the AMS unit. There's 64 of these filters in the fat boy, and they filter particulates down to 0.5 microns. The advanced mechanical separator is being started for this demonstration. The unique feature of the AMS is its ability to backwash the media every 4 to 6 seconds so that the media doesn't get clogged up for continuous operation. You can see the various pods within the AMS. They're made out of stainless steel. The advanced mechanical separator is not only highly efficient, it's also highly reliable because it utilizes pneumatic technology, whereas electromechanical pumps might fail. The whooshing you hear every so often, every few seconds, is the system backwashing its media filters, keeping them clean.
Alright, everybody might want to stand back and just get a little bit messy.
There's our dirty water coming out. So there's your system right there. Our final product right here in my right hand. You can see that the clarity on this one, if we get a good light behind it, is very clear. It's probably 1 NTU. This is our reject. Well, we took the dirt we took out of this original product, which is probably NTU well over 100. And this is still salt. Well, no, this is dishwater. So this is probably drinkable. I'm not going to drink it, but it's drinkable.
On the reject water side, the water containing the constituents that were filtered out during electrocoagulation are sent to a filter press. This particular press has a row of 20 filters. The water is forced through these filters and the contaminants collect on the filter itself, later to be scraped off into the bottom of the pan, where it's collected and sent to a landfill. In this case, it's non-hazardous clay waste. The water that makes it through the filter press is returned to the beginning of the process, which is the 8,000 gallon holding tanks you saw earlier. This allows us to reprocess the water, achieving a higher water yield. Global Water Solutions is revolutionary in its approach to processing contaminated water for reintroduction into the environment or for use in municipal water systems. Its chemical-free processing, low energy consumption, and scalability makes it a unique technological process that can be applied to virtually any industry worldwide. Global Water Solutions, making water safe.